Hello, welcome to this webinar. Don't know how many people attended. It's difficult for me to identify, but the most important is to cover the HVAC system, discuss what the HVAC system can provide, and the VMF technology. So while waiting maybe from some other people to connect, I will just play some video while waiting. Is there some more people who can connect? So I can start the the the, the master class. Yes, today we'll discuss a bit about a specific application of the project. On the VMF applied in the office building in the Central Africa Republic. So let me share my screen. Let me start from the beginning. Start it from the end. Okay, I think at this stage, can start from here. Like I said, while waiting for the people to connect, I will just go through the introduction. I also play some video while waiting. Maybe I will play that video twice while waiting. Any people can join us tonight to discuss a bit the master class about integrated HVAC for green building. This workshop, or we can say master class, is brought to you by Shift in partnership with Danvern. Shift is a green building consultancy firm based in the UK. Danvern is a manufacturer of the VMF technology based in Bulgaria. So if you have any project, just in case you have any project, you can scan the QR code and submit your project, so we can look at it together. We can try to see if the VMF could be suitable for your project, because we have a kind of checklist that we develop. We call go or not go tools that we can help us to assess the project, because this technology is very suitable for project who might need at least at least four function for the VMF technology. So today is our second master class. We're focusing on more application. Like I said, here is more action than just conventional webinar and just maybe academic approach. Here is more practical. We want to show how VMF, the new area of HVAC, total HVAC concept, are coming through. So the VMF is the ultimate energy saving total HVAC concept. When you mean total HVAC, mean we provide all the four pillars of HVAC system: heating, ventilation, AC, and cooling in our concept. Myself is Dr. Blaise Mempo. I am Dr. Blaise Mempo. I'm Danvern, Africa Market Development Lead. So I promote through my through Shift, who's our company based in the UK, main company based in the UK. We're actually working in different countries. Actually, we have collaborator in Nigeria and Zimbabwe and Cameroon. As you can see, that is actually the Denver factory based in Bulgaria, where we visited with the team from those different countries. I'll play this video just for like a little introduction, so for us to set the scene.
Welcome to Danvern's accredited professional program, where we aim to lead the green building industry through innovative HVAC solutions. This program is designed for sustainability professionals looking to gain a competitive edge in the field of green building certification. Our key focus is Danvern's VMF technology, a complete HVAC concept integrated with building management systems. It covers heating, cooling, ventilation, domestic hot water, and humidity control in cooling mode, all while ensuring high energy efficiency. Through this program, participants will depend their expertise in using VMF concept to meet green standards like H, LEED, and more. With VMF technology, professionals learn how to optimize building performance, reduce energy consumption, and enhance indoor air quality, all crucial elements in achieving sustainability certifications. The program not only only offers technical training but also provides marketing insights to effectively communicate the benefits of our systems to clients and stakeholders. Danvers VMF concepts are versatile and designed to serve multiple sectors, including healthcare buildings like nursing homes, hospitals, and clinics. They are also ideal for retail spaces such as leisure centers, shopping malls, and supermarkets. Furthermore, our technology is a perfect fit for educational facilities, including schools, universities, and sports centers, as well as for office buildings or mixed-use developments combining office and retail spaces. After completing the structured training and certification exam, you'll receive an official accreditation, joining a network of certified professionals promoting VMF technology worldwide. Empowering you to lead green building projects with confidence. If you're an architect, engineer, or sustainability consultant, this program offers a golden opportunity to stay ahead in the green building industry. With our global support and training resources, we are committed to making your journey towards sustainability impactful and rewarding. Ready to join? Visit our website to register your interest and get started on your path to becoming a Danvers accredited professional.
Let me play that again because, like I said, it's very, very important to listen maybe many times to understand exactly what we're proposing while waiting for maybe one or two or more people to connect.
Welcome to Danvers Accredited Professional Program, where we aim to lead the green building industry through innovative HVAC solutions. This program is designed for sustainability professionals looking to gain a competitive edge in the field of green building certification. Our key focus is Danvers BMF technology, a complete HVAC concept integrated with building management systems. It covers heating, cooling, ventilation, domestic hot water, and humidity control in cooling mode, all while ensuring high energy efficiency. Through this program, participants will depend their expertise in using VMF concept to meet green standards like H, LEED, and more. With VMF technology, professionals learn how to optimize building performance, reduce energy consumption, and enhance indoor air quality, all crucial elements in achieving sustainability certifications. The program not only offers technical training, but also provides marketing insights to effectively communicate the benefits of our systems to clients and stakeholders. Danvers VMF concepts are versatile and designed to serve multiple sectors, including healthcare buildings like nursing homes, hospitals, and clinics. They are also ideal for retail spaces such as leisure centers, shopping malls, and supermarkets. Furthermore, our technology is a perfect fit for educational facilities, including schools, universities, and sports centers, as well as for office buildings or mixed-use developments combining office and retail spaces. After completing the structured training and certification exam, you'll receive an official accreditation, joining a network of certified professionals promoting VMF technology worldwide. This isn't just a technical journey, but a strategic one, empowering you to lead green building projects with confidence. If you're an architect, engineer, or sustainability consultant, this program offers a golden opportunity to stay ahead in the green building industry. With our global support and training resources, we are committed to making your journey towards sustainability impactful and rewarding. Ready to join? Visit our website to register your interest and get started on your path to becoming a Danvers accredited professional.
So, like I mentioned earlier, we already have Danvers accredited professional in Zimbabwe and Nigeria. We also see it's open to global, it's global opening. Everybody want to be trained to know how to implement VMF in the real world project. So we are open, like I said already. We have some accredited professional in Zimbabwe and Nigeria already. That maybe in the future we will do some event or maybe some specific masterclass related to those different countries where we have also in Cameroon. I didn't mention Cameroon, by the way. So in the future, we will look at the possibility to do kind of more country-focused masterclass to look at the same possibility we can extend our application in those countries. Yeah, today we will discuss again. I will discuss what this masterclass is about, and then also what is VMF, and carry on with the application, because this is the second week of our masterclass where we discuss a bit really real life application of a project based in Republic Central Africa. And then we will look at the edge alignment and call for project express of interest. If you have any, you can scan the barcode anytime to submit your project. And then what will come next week? And we will now open with the QA session if we have we have time to cover those. So again, thank you again for staying connected. You can share also with people, relevant people who might be interested, mostly engineer or maybe HVAC or building owner who have or facility engineer who are looking for really efficient system. So we will really appreciate if we can share with them this presentation. I mean, mostly this masterclass to give them the possibility to come and be aware about this new era of HVAC system. As you know, at Danvern, we are trying to solve a very huge problem that you can feel we are currently facing in the traditional HVAC system. So for decades, as you know, HVAC system have been kind of approach that we kind of mechanical add-on. We take that as a mechanical add-on. We just select system, size it, install it, and hope that it can perform. Most of the time, we need. I think it's just recently year where we're working properly. The building load, the cooling load, everything that become a bit more precise. And then this masterclass is very important for one of the reasons being that the HVAC is one of the high energy consumer in building, in mostly commercial building, and also the complexity in terms of installation. So that's a really it takes most time, but most budget in large project. So investor or any building owner sometimes a bit worried about that's the most. What's the point if you design a very nice building and the people cannot live comfortably inside? It doesn't make sense. If the office building, hospital, or maybe educational building, all those buildings, we need comfort. It does isn't they are not comfortable, mean people will not be happy to be in the building. Maybe they might perform, they might not perform well. So when you look at the HVAC system, it represents at least between 38 and 55% of total energy consumption. That's huge for a large building. That's really huge. It's a lot of pressure on normally on the budget, maybe cash flow or certain company. Because like I mentioned earlier, if the building are not comfortable, people will not be happy to be in the building. So if they are working, it's an office building, people might not also perform better. And looking at normally globally, building are kind of responsible for between 47 and 55% global greenhouse gas emissions. So this also related to the construction sector, close to 50. So also, sir, if you look at the recent year in Europe or mostly in the UK, where I'm based actually, we're talking about net zero, and it's difficult to achieve net zero with low energy efficient, or maybe let's say with inefficient HVAC system, mostly for commercial building, like I mentioned already earlier. So if you have but you have no comfortable with no high energy efficient system in the building, that means energy consumption will be high and your carbon emission also will be high. So it become a bit difficult to reach to meet even the standard, because most commercial building is a kind of the regulation I go to forcing them to look at to reach net zero by 2050, which it's a bit near. You look like it's a bit far, but it's also near because we need to appropriate technology to meet those targets. So here is the work we are putting on the table. Yeah, one of the additional systems, like I also mentioned, is still on the traditional system. You look at them, jungle complex system, like most commercial buildings also have different components representing. You can have a separate unit for maybe like a heating system, another one have manage hair handle unit, another one maybe for hot water. That result maybe most of the time they all have maybe pump or fan or maybe circulating maybe a compressor also. Most of those, if they are inefficient, and they need to work together. If they don't communicate together, also it's a big problem. Apart from being inefficient, they also occupy a lot of space in the roof. So that also create another problem. So a simply bigger challenge here is how to avoid to look at how that we can have a simple system who can help us to reach those those needs. And like I said, in Danven, we not just improve, but we create a completely new HVAC universe. What I mean, like I said before, uh, if you look at the traditional system, mostly they are most of the time really focus on large quantity of or refrigerant go around through through the building. So if you or whether it's VRV or VRF or maybe the water through chiller or anything, any cooling system, those have a lot of refrigerant going around the building. So actually, instead of be looking kind of architectural in terms of distribution, in terms of also let's say if I can summarize it, put it this way, legacy in terms of HVAC system is that system are being heavily rely on high efficient, on high refrigerant going around through the building. I'm sorry, I wanted to stay here to explain very well. So refrigerants, like I said, legacy system is kind of refrigerant everywhere. And then also, whereas in the hybrid system, what we mentioned, hybrid system VMF solution is that it's hydronic, this distribution mostly water, and the intelligent air management is not fixed, it's not based on static load only, but based on load management. The demand is also managed. I will explain that later. So that what we summarize, that we create a completely new HVAC universe. So it's not about really focusing only on static system, or maybe here we control fresh air, the latent load management, like I mentioned earlier, and then that also reduce stress on electricity consumption. So if you look at the application of conventional system, like I mentioned earlier also, we just design, install it. Most time we hope that it might work. Sometimes it's very difficult to control the load around it, and even when you model, you might still missing some parameter. Or whereas here with the VMS system integrated with the BMS, we easily control everything, the loads and also the latent load management mostly around the building. That also help to have a great impact on the energy consumptions. So to summarize everything is that we can say we are replacing the complexity with the very light and simple system. So VMS not only serve, it cannot just help to serve at least 100% versus VRF system and the unit setup, but it require less maintenance because is there no refrigerant go around through the building, like I mentioned earlier, and it's combined with chill beam. With chill beam also require less moving part, and the system I easily replace the more than 3 conventional system. The VRF, which is kind of providing AC, the air handling unit provide the ventilation, the dehumidifier, and also hot water system. You see, it's more than 4 systems that can substitute with the VMF. Or VMF provide everything in one single monoblock plug and play system. Just plug and play. It's not heavy hardware that you have to install in the roof, pull up there, with welding there, refrigerate all through the building. Here is simple monoblock system, plug and play. Yeah. Also, I need to remind you that it's not we are not talking about prototype here. We're talking about something already working. We have several projects on part. We are already some will be implemented. Are currently working. We are more than happy to jump in the call with you and present to you real life working performance. Or you can also visit. You are free to we are welcome to visit the install system in Bulgaria and other countries that we already installed the technology. So if you are really have a real life project that you want to test or you want to see how VMF are working, you are more than welcome to contact us so we can organize a visit to the factory. You can also look at the technology in real life. We can also visit some project site where you can see how the project perform. We have a chance to discuss with people using the project. We're using the real life technology. So we're not talking about, it's not about a prototype. We are talking about a real life project here. It's very important. Real life technology. You have been working for the last 7 years. It's not today that VMF is out. No, you have been working for the last 7 years, working perfectly. So you have been monitored and tested several times with different working conditions. So we can guarantee you now we are really confident with our technology, and the technology are doing good. So we believe that it can substitute or it can really deliver everything we're declaring here. That why in the next slide I will take full responsibility. We take full responsibility to provide all the solutions. So we don't share responsibility. We take full 100% responsibility. So if it doesn't perform, we back it up. That's very important. So that's already like I want to put that claim already. It's very important. I will play a video here, kind of summarize everything I just discussed. Maybe that will summarize maybe better, and then maybe I will play it twice just to repeat it several times so we understand exactly the point I'm making here. It just matter what I just covered earlier.
Today, we're going to talk about a piece of tech that is completely changing the game for how our biggest buildings, well, how they breathe, stay warm, and keep cool. It's called a VMF system, and honestly, it's a huge leap forward. But to really get why it's such a big deal, we first have to look at the problem it's built to solve. So let me ask you something. When you picture a big office building or a hotel, what do you think is using up the most energy? Is it all the lights? The thousands of computers? Or maybe something else entirely? Yep, if you are thinking it's the climate control, you are absolutely right. The amount of energy is just staggering. In a normal commercial building, the HVAC system, that's all your heating, ventilation, and air conditioning, can guzzle down anywhere from 38 to 55% of all the energy used. That is a massive slice of the energy pie. And that really brings us to the core of the issue, doesn't it? Our buildings have a serious energy problem, and the way we've been doing HVAC is right at the center of it all. Think of it like this. For decades, the climate system in a big building has been like one of those old component stereo systems from the 80s. You've got a separate box for the heater, another one for the AC, one for ventilation, maybe another for hot water. They're all kind of Frankenstein together with a mess of wires and pipes, and they don't really talk to each other. It's complicated, it takes up a ton of space, and it's just not very efficient. So if the old way is that clunky stereo system, the solution is much more like a sleek, modern smart speaker that does everything in one. And that, right there, is where VMF technology comes into the picture. Okay, so what is VMF? It stands for Variable Multi-Fluid Flow. And yeah, it's a commercial air-to-water heat pump, but the real magic is how it puts everything together. It takes all those separate jobs, heating, cooling, fresh air, hot water, even managing the humidity, and it packs them all into one single super smart unit, the whole shebang. So instead of a whole room full of different machines, you just have one smart unit doing 6 different jobs. And it's not just about putting them in the same box, it's about making them work together perfectly under one brain. Let's just follow the flow for a second. There's a single master unit, usually up on the roof, that does all the hard work. It treats the air and water, and then, and this is a key part, it sends treated water, not refrigerant gas, down into the building. That water flows through these special units in each room that quietly use its temperature to either heat or cool the space. It's elegant and simple. Now, this all-in-one approach isn't just a neat trick. It has some incredible real-world benefits. The whole system ends up being smarter, way simpler, and a lot healthier. So let's break that down. Okay, let's get into the numbers because they are pretty dramatic. Compared to a standard conventional system, the kind with separate refrigerant units and big air handlers, a VMF system can use 75 to 100% less energy. No, that is not a typo. We're talking about, in some cases, doubling the efficiency. It's wild. And because it's so much more efficient, it just needs way less power to run in the first place. the total power you need to install can be 50 to 75% lower. And that means less stress on the power grid and way smaller requirements for those expensive backup power systems. This one is all about your health. VMF systems are designed from the ground up to use 100% fresh outside air. So there's no recirculating stale, old indoor air, which is something older systems do all the time to try and save a little energy. Here, the focus is just on giving you the cleanest, freshest air possible. I mean, when you put them side by side, the difference is just night and day. On one side, you've got the old way, a bunch of separate units, a massive footprint, super complex installation, and you're often breathing recycled air. On the other side, you've got VMF, a single compact unit that's basically plug and play and guarantees you're getting fresh air. It's a completely different philosophy. So how does it pull this off? Well, if you look under the hood, it's packed with smart tech. A huge piece of the puzzle is something called heat recovery. The system literally captures the heat from the air that's leaving the building and uses it to warm up the fresh air that's coming in. It's basically recycling energy that would otherwise just be thrown away. But beyond all the energy savings, think about what it feels like for the people actually in the building. It's a huge upgrade. Since only water is flowing through the pipes indoors, there's no refrigerant in the rooms with you. And those in-room units, no fans. So it's totally silent. You just get this gentle, consistent temperature without any of those annoying drafts. And it even controls the humidity. It just feels better. Okay, so let's zoom out for a minute. This kind of technology doesn't just exist in a bubble. It plugs directly into a much bigger conversation we're all having about sustainability and what the future of our buildings should look like. And this quote just nails it. Right now, being able to prove that a building is green is more critical than ever. Everybody, from investors to tenants to city regulators, is demanding higher and higher standards for efficiency and sustainability. And that is where a system like VMF becomes a developer's best friend. It's specifically designed to crush it on those tough green building standards like LEED, BREEAM, and EDGE. I mean, a single VMF unit can help you check off a whole list of requirements all at once, which makes getting those really valuable certifications a whole lot easier and cheaper. So what it all comes down to is this. The tech we use to build our world has to evolve. Systems like VMF are showing us a path to buildings that are not only lighter on the planet, but are also just plain healthier and more comfortable to live and work in.
So if we look at it now, what is VMF then? I will just show a short presentation from my colleague, Diane. We would like to cover a bit, a short definition of
Start
VMF.
with a short description of what is VMF. So VMF is a meaning is variable. It's too big. Variable multi-fluid concept. Not multi, but multi, because we have variable fresh air, variable refrigerant, and variable water all at the same time in one unit. As a description, VMF and or categorization, VMF is a hybrid. Very often you will be asked, what is VMF? Is it a VRF? No, it's not a VRF. Is it a chiller or heat pump? Yes and no, it's not. Is it an air handling unit? Yes and no. So VMF is a hybrid. And we have categorized it as a commercial air to water heat pump plus ventilation and humidity, relative humidity control. So with one, our goal was with just one unit to cover all 5 main functionalities that are required for every project worldwide. This is obviously space heating, space cooling, sanitary hot water, 100% fresh air or ventilation, and humidity control in summer, in cooling. Together with those 5 functionalities, we add another one, very important, which is the integrated building management system, or in our case called energy management system, because it's a higher level system that control the whole concept.
So what are we just clarify here? When he said VMF VMF is a VRV or VRF according to certain manufacturer. Yes and no. Yes, because he has a variable refrigerant, but unfortunately it's no, because the VRV or VRF most time have refrigerant everywhere. You have refrigerant outside in it and inside the building. So that's why it says yes and no. Yes, because there's a variable refrigerant flow going in our system. The compressor is variable also. A variable refrigerant, but it's completely stay outside the building. Then no, because the refrigerant doesn't go all through the building, so it becomes yes and no. So here, like you say, we can clarify as a heat pump, as a commercial heat pump. It doesn't have a static compressor, but you have a variable refrigerant, and then it's a chiller. Yes, or you can also yes and no, because actually outside is not variable refrigerant for the let's say conventional screw chiller is, but inside there's water going through. Here also we have water going through, but our water is going through the chill beam combined with the airflow, which is completely different from the conventional fan coil. So that make it also yes and no. So it's a heat pump, but not or maybe a chiller is not a conventional chiller system. So that it did make a big difference. So it's a yes and no. So I just want to clarify that yes and no. So because sometimes it's a bit. Somebody asked me a question last time. Why yes and no? Okay, and I think it's a bit clear for some participant now. So I will carry on with the explanation. So the main, you already explained all these substitutes. The system will substitute in we combine in one system. We make it monoblock. He already explained what we wanted to achieve. The 5 main functionality that HVAC can provide to you, and then we even went further by providing a economizer, which I will explain better. The economizers mean when the outside temperature is right, we bypass the compressor. The compressor doesn't work anymore, because most of the time in the conventional system, it doesn't matter if the outside temperature is good or not. The compressor are still working. The compressor are still cooling or still heating. So here, with the simple system, we try to reduce that. So by reducing the amount of component, we end up reducing the completely footprint. We're kind of replacing, like I said, separate unit with the elegant one, who can be single because the monoblock already explained that. Who can also be easily be certified, because you can meet several points. You see all those parts are going away. That's a very important move here, that we save a lot of labor costs, a lot of maybe kind of maintenance costs also that have been taken away, because here we provide monoblock system, easy to install and plug and play, like I mentioned earlier. And then inside, this one was an external unit, but inside now we have our internal units, is mostly rely on with some kind of active chill beam technology. Like I say, if you look at it, you have nozzle. Both are working through. We have water flowing. We have fresh air, like we hear on the video. It says it's very silent. It's hygienic because 100% fresh air. I hope people understand what we mean by 100% fresh air. Most time, the conventional cooling system using cassette, what we call the internal unit, is a cassette. Those cassettes recirculate the internal air. They don't take air from outside. Imagine you are in the hospital environment. You use the internal air you just recirculate the same air, like the video mentioned also, is to kind of make it affordable according to them. So by using the internal air, the same air you are circulating, or here with this system, we provide 100% fresh air. So most of the time we renew completely the air in the room. We don't recirculate any air. So that make it also very useful, very hygienic compared to the conventional system. And as you can also notice, in this system, we have we don't have any fan. We have no fan in the system, because the fan is also outside in the monoblock system. There's no fan here. So it means there's no noise in the room. Like you can see on the conventional cassette, the noise going on. Here, there's no noise. It's very silent. and very comfortable because there's no indoor refrigerant already mentioned. Since there's no fan coil, the condense also no condense part because there's no condensation going on in there. So, and additionally, because of that, since there's a all control and only one simple control, all are controlled from outside, make sure that the air coming in are comfortable, are really in the, it really meet the need of the of the user. Now, the advantage here that the system have the integrated BMS. It control everything. We can even the possibility that Danven can connect from the distance. There's monitor the distance monitoring. We can monitor from the distance through the gateway, leading the minimum service requirements. So even you have an issue, we can even spot it from the distance. That's the huge advantage here. And you don't need to move people to do your maintenance if there's anything that going on, because like I said, the system is monoblock. It's easy to manage. So designed for lifetime extension. Also can reduce on-site labor. Already mentioned that earlier, because monoblock easy to install, plug and play. Yeah, and the connectivity, I also mentioned the remote access. Already mentioned that. The integrated BMS energy management system that have been provided is already centralized. That is a part of Danven technology, integrated part of the technology. So if you are going for a conventional system, like I mentioned, also you need internal. Most of the time, it's not about the basic control here. We're talking the true BMS system through the Modbus, and then all the conventional BMS system. So if you have a building that you want to monitor, you don't need any additional BMS system for the HVAC system. If you use total HVAC, you use our the total HVAC system. And then also the system might be centralized. So there's a possibility to integrate solar system, because the VMF can act like a brain of the building. It's successfully the integration. If we put it like a solar system, since our system are relying on there's a buffer tank for water, for hot water. If we integrate with the solar system and the outside temperature is good, the solar will be prioritized over the compressor. The compressor only work if the outside solar is not sufficient to do the job. Now, additionally, also in terms of the grade, because all combined system create a very low peak demand. I already mentioned that earlier, in terms of reducing the installation power. Also integrated with the domestic hot water. I already also mentioned that. Waste heat are being used because there's heat recovery integrated. So the waste heat from the condenser are being used to provide heating, to heat the water, mostly in summer, most time in summer month, or maybe in Africa, in, let's say, tropical climate, where they can use where the cooling, we can use the heat, the condenser, the heat from the condenser. You can we can kind of recover heat from the condenser to provide hot water for the hotel application, hospital application, depend on different application. Yeah, and also, yeah, as you know, it's good where the grade sometimes are not reliable, mostly in different developed country where the grade are not really reliable. HVAC must be designed with the electricity infrastructure in mind. So we want small peak demand is better. If you have small peak demand, it means you can easily install a PV system. Also, small generator, you want to put a small generator. And here, having low risk refrigerant is much better, because also it gives you a better ESG profile and better eligibility for green finance, because you reduce your impact on climate. So that's another advantage here that the VMF can bring over a conventional system. With all the benefits we are bringing in, yeah, the capex might be Depend of the country, depend where you are, but the capex it depends also the functionality you are looking for. If you are looking for the fast functionality, 100% I can guarantee you that looking at the fast functionality plus BMS, if you look at the conventional system that you want to put together, 100% VMF will be cheaper. But if you are looking maybe 3 functionality or 4 functionality, sometimes the capex might be a bit higher. But if you look at the long run in terms of in terms of operational cost, the VMF will be much better because it will reduce the cost with additional benefit, low labor, quite low maintenance. Really quite reduce on the number of company who can intervene on site, because now it's a one system providing most functionality. So you need less labor. Return on investment are perfect, because also remember I mentioned about the economizer. When the outside temperature is right, you can have free cooling or free heating. Those are also advantage. So there's so much advantage compared to a conventional system, to be honest, in terms of operation. Like I said, this is not a prototype. We're not talking about new technology. We're talking about 7 years ago. You have been working, implemented in some project already. So you are more than welcome. You have a project, submit your project. So we will look together. You are welcome also to visit the factory in Bulgaria, even visit real life project you want to. We can organize that for you. We're not talking about something that then like I said, he has a BG management system integrated, so we can go back, we can look from historical data for you. You are more than you want to be to see exactly how you're working on ground. So the system is edge aligned. There's good alignment with the edge. This system can meet more than 8. If we want to also include the low impact refrigerant unit, we can say 8 measure of edge. Edge will already be combined with all the certification system. So here there's that huge advantage also in terms of you are looking for green certification. Most people do. Those who are looking for net zero building. VMF also give them that huge advantage in meeting most technology only with one. Most measure with only one technology. One of the great advantage here is a variable we mentioned already, the variable tree, mid-tree fluid. The variable refrigerant I mentioned earlier through the compressor, and the also variable through the pump, and also through the electronic for the water for the air. So that can be easily controlled through monitoring system. So that like a meter check, a smart meter for energy and cooling, heating and hot water. So those are the great advantage that can be claimed through edge, variable speed, compressor and so on. And although I mentioned this already, the economizer, when the outside is good because the heat recovery system integrated here, then we have a good heat recovery system will be integrated on the VMF system, on the VMF. So we have played heat recovery system, control flow. If you are claiming for edge, you go for there's a air free cooling using the air. We bypass the compressor. I mentioned that already. When the outside temperature is appropriate, that can also be used. You can, you can just provide you fresh air, just filter the air and provide that to you, with a great advantage that also save energy and save a lot of load on the compressor. Space heating and we have buffer tank. Those buffer tank that provide this for 2, one bigger one for where you can store, like I mentioned last time. There's possibility you can use to store heat or cool. Maybe you can also program due to the BMS integrated. We can even look when the outside temperatures. When the energy is cheaper, you store heat or cold that you can be used. Remember, most African countries have power. If there's no power, we have a small system where be installed. We install some power also. That also can be useful to replace a fossil fuel boiler. Okay, then optimize water temperature. The average 35 degrees, very good for underfloor heating, which can easily be integrated. So to claim, we see it under edge application. For edge, we have measure like the two measure EEM 16 and EEM 18. They're for for space heating and hot water heating. So in that case, you select heat pump, 100% heat pump, because the heat pump here, the heat pump will provide the hot heat, and for space heating, you also provide applied heat pump. That we have a complete guide for that. It's anybody interested, you can ask for it. We have a complete guide for that. We can allow you to look at those applications. Now we'll go a bit. We'll look a bit kind of project application here. Like I mentioned, the introduction, that we'll discuss a bit how the project can be applied in current building that we're working on in Central Republic of Africa. Yeah. Also, repetition is not it's good. It's pedagogic, like we said in French. Here we are not talking about prototype. We are proven system ready to scale. It has been applied already. I said again, it can be applied to retail, office, hotel, hospital. If anybody interested, you can submit your project. If you want further, you are more than welcome to come and visit the applied project. You are more than welcome to visit the factory also in Bulgaria to see the real life, how you be manufactured you want to. And also, if you want to see a real life project, you are more than welcome to submit the project. We can see that. So VMF is perfect for commercial building and institutional building, including like hotel, hospital, indoor swimming pool, gyms, retail space, and even school. Whether it's a new or for retrofitting, VMS is it can easily be adapted to all those applications. And in the coming weeks, we're going to go through all those different applications in the coming week. So today is just about what exactly. Today we're just focusing on office building in the Central Republic, but in the coming week, like I said, we'll cover most of those the indoor swimming pool, hospital, and other projects. I repeat again, we take full responsibility of the project that we are involved in. We provide the hardware, we provide the software, we provide the performance, we guarantee the performance to you. So it's 100% responsibility, zero complexity, because we know our technology, we trust our technology. It has been tested for the last 7 years, I repeat again. So it's something has been proven. We know that with a single unit, you can achieve 100% HVAC system in a small building, maximum 1,000 square meter. You can go fully in one unit, and then you have a bigger building. We can go with several unit, kind of centralized, decentralized system, because that gives you a possibility to combine a system across. Yeah, specific case study here, like I'm going to look a bit. We're going to look together with my colleague. We're going to intervene soon. He's a kind of because actually he did the pre-recording because it's very late in his country now. It's very late in Bulgaria now. It's more than 20. It's already 9 p.m. So he couldn't present. So he did the pre-recording for us, explaining the implementation. So the project is about what? It's an office building based in Central Republic Africa. The gross area above 4,000 square meter, where we provide cooling, kind of cooling and some ventilation, humidity control, small domestic water, because there's a canteen there, and there for washing and so on. And the BMS system was a very big requirement. They really wanted to have a control. We wanted to integrate a BMS on this project. And here we provide four VMF. Before we came in, there's also design were being done already. This project has been covered already by, initially we look at the climate first. We got to understand the climate. If you look at the climate here, normally you look at the climate, that's a kind of tropical climate, like in the Central Africa Republic. You look, the green one is mostly, you can look here, is a dehumidification. So if you want to get this climate, most of the year, we have 78% requirement is dehumidification, not AC. not if you look at the 15, number 15 here in red here, number 15 is a cooling and dehumidification. Or cooling mean using like active system, like AC system and so on. But unfortunately, on this system, or most of the time it's dehumidification. But unfortunately, in the conventional building, most of the time we put the VRV, everything to provide comfort, to provide the comfort. Or if you look at where just only part of it, which is less than 20% would require normally active cooling. This one, the one in red, require the active cooling and dehumidification. Active cooling and dehumidification. So we believe that the VMF was a suitable technology for this application because it can easily provide those full functionality, and with dehumidification already integrated, it was a excellent project, excellent fit for this building. So that what we compare a system, we design a local manufacturer also, I mean a node or supplier design the VRF system with the air handling unit for the same building, and also the possibility to look at the water cool through chiller for the same building, and also we provide the VMF with the air handling unit. That way, what's a bit that what we are going to compare here. We're going to compare those three systems in terms of benefit the VMF can bring compared to other technology. Yes.
So the first project that we will go through is actually an office building that is located, and this is how it looks like. That is located in Central African Republic. As you can see it's 6 level. So the first project that
sorry.
So the first project that we will go through is actually an office building that is located, and this is how it looks like. That is located in Central African Republic. As you can see it's 6 level, 6 floor building, and it was originally designed with a classic. We call it classic system, VRF, plus ventilation, basic ventilation. So what we did here is, of course, redesign with VMF, and I will show you how it looks, the general design for 1 or 2 floors out of the whole building, because they're very similar. So on one of the pages that you will see, we have the ventilation part, the duct part, and on the next one is the water part. So with VMF, we have a very simple architecture in every room. As you can see, we can have a single room like this one, and in this room, I will zoom it even more. In this room, in a single room, we have obviously the internal unit, the chilled beam, and only one suction grill. Below that room, you can see another one with a little bit bigger room with 3 internal units, 2 suction grills, and many more like this. You can see different examples: single room with 2 internal rooms, 2. Here it's more interesting. We have a conference room, much bigger space, much bigger room. So here we have, what is that? 16 actually internal units, chilled beams, and 5 suction grills. And the architecture, it's repeating itself for every room. Very simple. Also, for a very small rooms, as you can see in this part, there is no even internal unit. There's only supply air and return air. So basically we do the cooling and the ventilation only by air. On the next one, you will see the water part of the system. Every internal unit is connected via pipes to the water boards on the left and on the right side, and these water boards are coming here. You can see some more. These are very, I would say, standard distribution water boards, and the water is coming obviously from the buffer tank. We will go through that also. So going back to the first, the air side, I repeat, the architecture is very simple per room. One internal unit, one extract grill, and also very important, for every room we have one supply and one extract air regulation valve. On the water side, it's also very simple. We have only pipes and water distribution boards on each floor. We can have several. So for this floor, we can count them 1, 2, 3, 4, 5, 6 distribution boards. And you can see the hydraulic, the principal scheme for that floor. So this is the biggest floor in the building. So for this floor, we have 2 VMF units working and supplying cold water to one big buffer tank, 1,500 liters. And from that buffer tank, we go to the main distributor, and from main distributor, we go to the floor distribution water boards. Very simple but reliable scheme. We also have the water tank. We have a small water tank here because in the office building, the demands for domestic hot water are quite small. There is no there is no showering, only washing hands. So that's why we need a small water tank. But this is how it looks, the general scheme for the whole floor. So 2 VMF units, and then the buffer tank, the hot water accumulating tank, and the water distribution boards. Similar structure we have on the other floor a little bit. On this one, it's the floor, it's much smaller. So basically we have small individual rooms with one internal unit inside. We have 2 kind of meeting rooms with 2 to 3 internal units. Very simple structure, very simple architecture. This is the water part. You see for this one, for the previous floor, we had 6 water distribution boards. In this one, we have 1, 2, 3 distribution water boards covering the whole floor. And this is how it looks, very similar, the hydraulic scheme for this floor. You see for this floor, because it's much smaller, we have only 1 VMF units with the same structure, with a buffer tank, half size from the previous one, 800 liters, water tank, and again, the water distribution boards. So we have, I repeat, 6 floors on this building, and only one of it, the first one that I showed to you, it's significantly larger than the rest, and the rest floors are very similar to this one. So once we make this, we call it a pre-design with the VMF. A very important part of that first step is to make a comparison analysis between the original or the classic system, which is VMF and air handling unit, versus the VMF. And in this particular case, for that building, we added another one, which is a combination of water-cooled screw chiller plus air handling unit. So what is important in this comparison analysis? We include, most importantly, the installed electric power input for the whole HVAC system. We add also the refrigerant quantity for each of the systems. So as you can see in the original design, there are 7 external VRF units. We have the installed power for 2 air handling units. We have additional 2 external VRF units supplying cold water or cold refrigerant for the air handling unit. So the total installed electric power for this project is 426 kilowatts. And then we have calculated the approximate quantity of refrigerant for this project, which is nearly 246 kilograms of refrigerant. That very important here. A big part of this refrigerant quantity is inside the building in every single room. On the right side, we have a combination of water-cooled screw chiller with air handling unit, with a cooling tower, fan coils, etc., etc. So the total installed electric power is significantly smaller compared with the VRF, and the refrigerant quantity also is significantly smaller, 82 kilograms. But when we go to our concept of VMF, and on this project we have, as you can see, 4 pieces of VMF in total, 1 additional air handling unit with heat recovery. Our total installed electric power is 91 kilowatts, which is a huge difference compared to the VRF plus air handling units, more than 4 times and more than 2 times smaller than also the water-cooled screw chiller. The same difference goes for the refrigerant quantity. In our case with the VMF, we have only 40 kilograms of refrigerant, but this 40 kilograms are located outside the building on the roof in the units itself. So no refrigerant inside the building. So normally we produce this kind of comparison sheet for every project that we work, and you can see, as you can see, the differences are significant. I repeat, here you can see 91 kilowatts for VMF concept, 426 for the VRF plus air handling unit, and 202 kilowatts for water-cooled screw chiller plus air handling units. 40 kilogram versus 246 versus 82. Massive, massive differences. And this is how it looks, the structure for every project that we do as a pre-design. I will take a short break and go for the next project. So the first one is, I repeat, office building, 6 floors. We have 4 VMF units plus 1 additional ventilation unit with heat recovery. So
you can summarize the good result here from the summary that you mentioned, or maybe from the introduction I did for the case study. We clearly have 91 kilowatt. That's an installation power. Installation power, I mean energy demand for the installation power. As you know, most countries you need to have this before going to the power supplier to make sure they can design, or even you want to buy a generator, you need to make sure that it can fit. So they give already low installation power compared to the chiller with the 200 and the VRF system with 800 unit, who are going more than 426. So even double both chiller, I mean VMF and the chiller, they see very low energy consumption compared to the conventional VRF system. It's really important. Additionally, like I also mentioned, we have a kind of auto control operation, because the VMF all of them are integrated BMS system, intelligent load management. They be integrated already on the system. We really also reduce the energy consumption between 5 and 6 kilowatt compared to a static system. The demand is most of the time that the huge energy consumption compared to the anything we have variable load or variable consumption will be much better, because it changes according, or the energy also the consumption will change according to the demand and maybe the load. That's on the advantage that this system are bringing in. I'm sorry, let me go back on the normal presentation one here. Oh, I didn't choose the right one. I choose the right one, yeah. So like I mentioned before, so the total in terms of economic and data matrix, just to summarize what I already discussed, is coming from the analysis that my colleague did. Your total installation power is 91. If you look at the chill, 200, and the VRF 426. Total refrigerant in kilogram, we have 40 is all completely outside the building, not inside the building. Whereas the VRF is 246 and the chill 82 kilogram, which that still give the VMF very low. And in terms of footprint, I mean the primary unit, we have 4 compared to VRF 7, and the children with bigger. If you look at the infrastructure in terms of structure, architecture, they're taking more space. And what I mentioned also about the auto control or the capability in terms of load control, load management, the VMF already integrated the smart meter will help to control also, to assess the load and then provide the power, or maybe the compressor will act accordingly. Or if there's if the outside temperature is much better, the compressor will not, they will even bypass the compressor and go directly, provide just fresh air in the building. That's another advantage that we have here over conventional system. The kind of strategy recommendation to finalize everything. So the OPEX is very low compared to the one minimum of 21%, even greater. And in terms of risk, because there's no refrigerant inside the buildings, the low refrigerant, all 40 kilogram, all outside. And then the smart operation that I already mentioned, that also save of 5 to 6 kilowatt. So that maximize the thermal performance while minimizing the energy footprint. So that's a huge advantage over conventional system. So the link now with the edge, like I also mentioned earlier, there's a possibility to meet at least 8 measure: cooling, variable speed graphs, fresh air preconditioning system, space heating, domestic hot water economizer, a smart meter for energy, and low impact refrigerant. So this building have been certified, not model. Certified. You can check it out online. You can check it out on Google. On the Edge Building website, which is already published. You can see the big impact here. We have reaching 83% energy saving, water, we are close to 33, but I'm focused on energy here because that's our main focus. And like I said, if you clear, you can see it online. It's there on the you can see there, it's online. You can visit the project online. You are interested to see the project. It's there online. So yeah. Where I was again? Am I lost? Yeah, I was here. Yeah. So yeah, the really I mean the VMF play a big role to help to achieve this amount, because like I said, with only one unit, we managed to reach off to actually 4 or 7 units who have been validated, who have been audited by independent audit, certified by Bureau Veritas. Those are the things that have been already been checked and validated. So well, while we say that it can match 8 or 7, we're not just declare it. It's something that have been proven. So that's really important. And also, I reiterate again, we're calling for project. Anybody have a good project you want to check if the VMF already is suitable for that, because like I mentioned, you need to make sure that what you are looking for, the minimum full functionality might be used from the VMA. That will be very, very cost effective for your project. But it's less than that. You can see this picture is one of the VMA already installed in one of the projects that really who's currently working perfectly. So the VMS is working. It's not. We're not in the prototype stage. We're in the scale up stage. So we're looking for project who want to achieve high energy efficiency, and then also we are looking to save mostly operational costs, because you can scan the code here and submit your project. You can even do that later because it's still be online. So we are open to one-to-one support for you. We can give one-to-one support, or you're even welcome to visit the factory, and to visit the project or any project site that we implemented already VMF. So we are not just here to sell or maybe talk about technology. We want to raise your awareness about the paradigm shift we are bringing in the HVAC world. So if you submit your project today, the support, you have full technical support. We provide you turnkey proposal using VMF technology. So like I also mentioned during the presentation, we have 100% full responsibility. So we don't just provide technology, we support you up to the installation and even operational phase. So we make sure that technology works. So we provide turnkey with the full responsibility. So please don't let this opportunity pass by. Prepare your submission now, and then scan this QR code and submit your project. So we'll be happy to support you. Yeah. What this for? We are looking for architect who are looking to for the simple system, elegant to integrate us current project. It might be also an engineer, HVAC engineer, who are looking for alternative solution. Who are mostly open-minded engineer who want to develop, who want to look at new approach or new opportunity in the UK or maybe in Africa. We are more than welcome. We are also open to other places of the world, as long as it's open-minded developer or engineer or architect who are looking to implement new technology, who can let them to achieve high energy efficient. We're also looking for edge expert or project owner who are looking for very efficient technology for the project. Yeah, if you are committed to building a smart, greener future, this is your moment to lead the change. You can implement VMF your project. I'm sure you will be happy, and you will recommend us. Yeah, what will come next week? If we receive any project, next week we'll kind of go through the technical review, the VMF, the VIP session, technical session. Otherwise, I might do another live like this just to demonstrate a new application, additional application. So I just carry on discussing application. So if I come on live, there's no project to go through. If I don't come on live, we are working on the VMF. We got a technology a project, and then we're working on discussing in closed door through Google Meet or Microsoft Teams. So, and then next week will be, if there's anything also, like I said, we will go through those ones. So please submit your project again. It's the last call for submit your project. I already mentioned that. So you can submit your project. We'll be happy to support you. And you are also more than welcome to visit the factory, also to visit any side of the project that you want to see how it look like, how the VMF look like. Building the future of green building. At Denver, like I said, we don't follow trend. We develop a solution and concept. It's a new concept. We cannot develop a new universe of HVAC system. We think we really make a big change. Okay, thank you again. Thank you for your time. If there's any question, you can drop on the chat because already past the 75-minute marks. So you drop your question on the chat. I'll be happy to answer or give you my comment. There's any comment to make. Oh, thank you again. Thank you for your time. Thank you for those who found the time on the busy schedule to participate at this masterclass. And also, yeah, you see the video seen online. It's on live. You can still share with your colleagues, share with people that have interest, who are project, who are looking for energy efficient, want to save money, mostly on the OPEX side. Yeah, hotel, hospital project, office project, or hospital, all those, residential. It might be also be retail center, office project, hospital. You are more than welcome to support your project. Again, thank you very much.